Welcome to Colonize the Ocean podcast, where we discuss oceanic colonization, exploration, and education with your hosts Adam Jewell and Brendan Traxler.
Okay, so let's try and unpack this puzzle, really, that the sources you shared lie out. I mean, we're always hearing about space, right? Amazing pictures, Mars landings, all that stuff. It grabs you.
It really does.
But then you look at our own planet, specifically the oceans, still so much we don't know. And it kind of begs the question, why all the focus, way out there when there's this massive mystery right here?
It's a huge imbalance. Think about pop culture. You've got Star Trek, Star Wars. Space is everywhere.
Yeah, totally.
But the ocean, well, there's 20,000 leagues, maybe SpongeBob for the kids, the abyss.
Yeah.
But it's just not the same cultural footprint. And that seems to mirror the real world focus, or lack of it.
Exactly. Remember the buzz around the Mars rover landing Mohawk guy went viral? Everyone was excited.
Oh, yeah, I remember that.
But then James Cameron, Mr. Titanic, Mr. Avatar, goes to the deepest part of the ocean.
The Mariana Trench.
Right, the Mariana Trench. And the reaction felt kind of meh, like it didn't capture the public imagination in the same way at all.
And that public perception thing, it has, well, very real effects on funding. So back in 2013, NASA's exploration budget alone was, around $3.8 billion?
Wow. Okay.
Now, NOAA, that's the National Oceanic and Atmospheric Administration, their entire budget for everything, weather, fish, research, everything, was about $5 billion.
So barely more than just NASA's exploration part.
Exactly. And the bit specifically for NOAA's Office of Exploration and Research, the ones actually doing the ocean discovery, a tiny $23.7 million.
Yeah.
Well, it speaks volumes about priorities, doesn't it?
It really does. So, okay, the mission for this deep dive, then, is to really get into the arguments from these sources.
Yeah.
The ones saying we need a major shift. A shift in attention, sure, but also, maybe more critically, in resources. Why focusing more on our own planet's oceans might be, well, not just a good idea, but maybe essential.
And maybe the most basic place to start is just how differently we connect to space versus the ocean. Accessibility,
Yeah.
the unknown. Well, space.
Yeah.
Like you can look up any clear night, right? See the stars, the moon, planets sometimes. It feels vast, but also visible.
Mm-hmm.
It sparks that wonder, that urge to explore.
Okay, I get that.
But the ocean, it's hidden. It's right there, but it's under the waves. We can't just, gaze into its depths easily.
That's a really good point. And the sources say we've explored, less than 5% of it? That's kind of staggering.
It is. And think about this. We apparently have better maps of the surface of Mars than we do of our own economic zone. The water is right off our coasts.
Seriously, that puts things in perspective.
It really does. And what's so fascinating about all that unexplored territory is the sheer potential for discovering life. New life. Scientists estimate something like 91% of ocean species are still completely unknown to us.
91%. Just imagine what's down there.
Exactly. I mean, the sources mention some of the weird and wonderful things we have found, like the deep-sea hatchetfish, or that ancient-looking frill shark, or that giant deep-sea woodlouse thing. Bathynomus giganteus.
Right, these sound like sci-fi creatures, but they're real.
They're absolutely real. And, while NASA keeps looking for life on Mars, and we remember the excitement about possible microbes or that arsenic life claim that got pulled back,
Yeah.
the ocean is already showing us amazing, tangible examples of unique life, like those ecosystems around the deep sea hydrothermal vents, life thriving without sunlight, using chemicals, chemosynthesis.
That's incredible. It completely changes how you think about where life can exist.
It really does. And this amazing biodiversity, it's not just, scientifically cool. It points towards a huge untapped resource potential.
Oh.
Which brings us neatly to the economic side of things.
Ah, okay. Economics.
Yeah. I mean, it's easy to forget how much the ocean already does for us. It produces, half the oxygen we breathe.
Wow. Half.
Yeah. It's the biggest single source of protein for humans globally. It's got minerals, potential pharmaceuticals, biotech opportunities. It's basically our planet's life support system, but we often take it for granted compared to, say, space.
That's interesting when you frame it like that. Because space exploration, people talk about the spin-offs, camera sensors, special materials.
Pugmere, Velcro.
Yeah.
Well, maybe not Velcro, but yes, spin-offs.
Oh, right. But actual stuff brought back from space, it's basically moon rocks, right?
Pretty much. A few hundred kilograms of moon rocks and dust.
Whereas the deep sea bed, that's looking like a potentially massive source of rare earth metals.
Right.
The stuff we need for like everything technical now, phones, batteries, green tech.
Absolutely critical elements. And
Yeah.
internationally, this is heating up. The UN has actually set up a framework, a first attempt to manage mining in international waters.
Okay, so there's some structure emerging.
Yeah, but the U.S., well, we haven't ratified the UN Convention on the Law of the Sea, so we're not actually part of that UN management structure right now.
So we're on the sidelines.
Kind of. Meanwhile, you've got countries like Japan finding huge rare earth deposits, apparently, in their waters and internationally. China's already sending out exploratory missions. There's a definite economic opportunity there that, maybe the U.S. is missing out on by not being fully engaged.
Okay, shifting gears a bit. Climate change. This is obviously huge. We know NASA does vital work monitoring the climate from space, right? Getting the big picture.
Definitely crucial work. But the oceans, they offer something more direct. They're acting as enormous carbon sinks. They've absorbed maybe almost a third of all the CO2 humans have pumped out.
A third? That's massive.
It's huge. And that leads to the question, can we maybe enhance that process safely, effectively? There are these geoengineering ideas like iron fertilization.
Seeding the ocean with iron.
Yeah, the basic idea is adding iron to certain parts of the ocean could stimulate phytoplankton blooms, and those little plants suck up CO2. Some research suggests it might even be pretty cost-effective compared to other carbon capture ideas.
But there's always a but, isn't there?
Well, yeah. We have to be careful. We don't fully understand the ocean's long-term capacity to keep absorbing CO2, especially as it gets warmer. That could change things.
And messing with ecosystems.
Yeah.
That sounds risky.
Very risky. We need way more research. Plus, there's the whole issue of ocean acidification. All that CO2 the ocean is absorbing is changing its chemistry.
Making it more acidic.
Exactly.
Yeah.
And that's really bad news for anything with a calcium carbonate shell or skeleton. Corals, shellfish.
Oysters, clams?
Yep. It could be devastating ecologically and economically. One estimate mentioned in the source suggests like $100 billion potential loss just in mollusk production. It's a serious, serious problem linked directly to that CO2 absorption.
Wow. Okay. Let's talk about food. Another basic need. Fish are super important protein-wise for billions of people, right? Especially in poorer countries.
Absolutely vital. But as we know, wild fish stocks are under incredible pressure. The UN figures suggest a really worrying percentage are overfished or depleted. We've seen fisheries collapse. It's not sustainable the way things are going in many places.
So what's the alternative? Fish farming. Aquaculture.
Aquaculture, yeah. It comes up in the sources as a potential solution. It can often produce protein cheaper than, say, beef. It doesn't use fresh water like land farming does. And it has been growing steadily.
But again, challenges.
Of course, there are challenges.
Yeah.
How will climate change affect fish farms? What are the impacts on wild fish nearby or the local ecosystem? We need better sort of standard operating procedures. And biodiversity is probably key to making aquaculture resilient too. It's complex.
And it's interesting, as the sources point out, NASA isn't exactly claiming to have space-based solutions for feeding billions, is it?
Not really, no. Their focus is elsewhere.
Okay, what about energy? Space has these, like, far-off ideas, right? Fusion, maybe. Solar power satellites.
Yeah, LENRs, low-energy nuclear reactions, things like that. Space-based solar. Very long-term, currently not really viable concepts for the most part.
But the oceans, they seem to offer more immediate renewable energy potential.
Much more immediate, yeah. Wave energy, for instance. There's a huge amount of energy in ocean waves globally.
Yeah.
And the tech, the wave energy converters, they're getting better, more commercially viable.
Weren't early ones really expensive or inefficient?
Some were, yeah. Like the old Salter's duck idea.
Yeah.
But newer designs, things like the Anaconda or Limpet systems mentioned, they're showing much more promise. Some projections suggest costs could actually compete with what consumers pay for electricity now, or even be lower.
And ocean currents, too. You hear about the Gulf Stream.
Massive potential there. The sheer force is incredible. A moderate ocean current can pack the punch of a hurricane-force wind. Just the Gulf Stream could, theoretically, provide a big chunk of Florida's electricity.
Wow.
But again, we need more R&D. We need to figure out how to deploy these technologies efficiently, make sure they work in different conditions, and really understand and minimize the environmental impacts.
Right. And there's oil and gas down there, too, deep down.
There are definitely hydrocarbon reserves in the deep sea, but the tech to get it out safely and sustainably is still pretty immature. And the environmental risks, especially somewhere like the Arctic, are just huge. Big concerns there.
Okay, let's touch on medical stuff. Space gets credit for some medical spin-offs, right?
Yeah, things like improved imaging, maybe some monitoring tech.
Yeah.
It gets mentioned.
But the ocean, it seems like it's already a source of actual medicine.
Oh, absolutely. It's proving to be an incredible natural pharmacy. There's a cancer-fighting substance found in a Japanese sponge that led to a breast cancer drug.
Really?
Yeah. Bacteria found near the Bahamas are yielding potential new antibiotics and anti-cancer compounds. Other things are being found that could help with pain, asthma, skin irritation. Even an organism from the Arctic has produced multiple new antibiotics.
And with antibiotic resistance being such a massive global threat.
Exactly. This kind of bioprospecting, searching for useful compounds in nature, is incredibly important. The ocean's biodiversity is a massive, largely unexplored library of potential solutions.
And didn't the sources mention horseshoe crabs?
Ah, yes. Their blood contains a unique chemical, LAL limulus amebicide lysate, which is super sensitive to bacterial toxins. It's essential for testing vaccines, drugs, medical devices for contamination.
So we rely on horseshoe crab blood for medical safety.
We really do, which also raises conservation concerns for the crabs, of course. But it just highlights another unique resource from the ocean. And imagine what else is out there in the 90-odd% of marine life we haven't even identified yet. The potential for future medical breakthroughs is just staggering.
Which brings us, I guess, to the big picture question again. How do we allocate our resources, our scientific focus?
Right. People like Amitai and Sioni mentioned in the sources argue for a fundamental rethink. Is the huge investment in space, inspiring as it is, maybe disproportionate compared to how little we invest in understanding our own oceans? Especially given all these tangible benefits we've just talked about.
It makes you think. And there's this idea of maybe strengthening NOAA, making it more independent, perhaps funding it partly by reallocating some NASA funds.
That's one idea put forward. Right now, ocean research is kind of fragmented across lots of different agencies. That might not be the most efficient way to do things. Maybe it leads to gaps or overlaps, lack of unified vision.
So maybe better coordination is needed, or even a dedicated agency.
Some argue for that, yeah. Better coordination definitely seems necessary. But maybe a dedicated Department of Ocean Research and Exploration could provide the focus and clout needed to really unlock the ocean's potential.
And what about how we explore humans versus robots? That's a debate in space, too.
It is. And in the ocean, robotic exploration, ROVs, AUVs, is incredibly effective. It's safer, vastly cheaper than human missions to the deep sea, and yields amazing science, just like robotic probes do in space.
Yet NASA still puts a huge emphasis and budget on human spaceflight.
Exactly. Despite the strong arguments for the scientific return from robotic missions, it's another parallel, perhaps, in how priorities are set.
So yeah, we come full circle. Back to that initial puzzle, this incredible, mostly unknown ocean full of potential resources, discoveries, solutions, yet it's kind of overshadowed by our gaze towards the stars. It really does make you question your own assumptions about exploration, doesn't it?
It really does. And maybe think about that provocative question from Senator Mark Bakich that was mentioned. If we'd invested just half as much in the oceans over the decades as we have in space, where would we be now? Think about all the tangible things we just discussed, the potential medicines, energy sources, climate insights, understanding life itself. What else might we have discovered? What problems might we have already solved or be closer to solving? What breakthroughs are still waiting down there?
It's a powerful thought to end on. Maybe that final frontier isn't so far away after all. Maybe the most fruitful one is right here, under the waves.